All right, guys, today we are looking at lesson 9.2, day 1, the Pythagorean theorem. It says, I can explain the Pythagorean theorem, and I can use the Pythagorean theorem to find unknown sides of triangles. So when we're looking at a triangle, the Pythagorean theorem can only be used for right triangles. And in this triangle here, the red and blue side we refer to as legs, leg A and leg B. It doesn't matter which side is A and which side is B. The hypotenuse, however, needs to be the side that is opposite the right angle. Okay, the hypotenuse is across from the right angle, and the hypotenuse will always be the longest side. All right, so we are going to do this exploration here to determine what the Pythagorean theorem is. So in order to do this Pythagorean theorem, you do need a piece of graph paper, and you can cut your graph paper in half, or you can grab a second piece of graph paper from the drawer in order to conduct this exploration. All right, so the first thing says to draw a triangle with sides measuring 3, 4, and 5 units. Let the legs of 3 and 4 lie on the grid lines, and then we're going to use a second grid paper to verify the hypotenuse is 5. Okay, then we're going to draw squares using the sides of the triangle, and then we'll sketch below what it looks like. All right, so I am going to switch over to a camera so you can see me trying this experiment here. All right, so I have my graph paper, and I am going to draw a triangle with sides measuring 3, 4, and then I'll show you that the other one is 5. All right, so if I draw my 3, I'm going to start right here and go 3 units. 1, 2, 3. Okay, then going the other way, I'm going to draw it with 4. 1, 2, 3, 4. Okay, now I'm going to take my second piece of graph paper, or like I said, you can cut your original piece, and I'm going to line that graph paper up so that I can count the hypotenuse. Okay, so if I'm counting the length of this hypotenuse, I can see that it's 1, 2, 3, 4, 5 squares. Okay, so that was my 3, 4, 5 triangle. So what I'm going to do with these sides is now I'm actually going to turn these sides into squares. So if I do that, this 4 is going to become 1, 2, 3, 4. Right, I'm going to draw a square with those measurements. I'm going to do the same thing for the other sides. So I'm going to draw a square with 3 over here. Oops. All right, and then on the last one, I'm going to draw a square with 5. I'm going to use my diagonal here. All right, I'll do my best to eyeball that. Okay, so now I have my 3 squares drawn. So if I look at the area of each of those squares that I just drew, I can see that a 4 by 4 square, right, a 4 by 4 square has an area of 16. A 3 by 3 square has an area of 9, and a 5 by 5 square has an area of 25. Okay, so that's my first picture. All right, then it's telling me to repeat this process with some other dimensions. So I'm going to do that again. We'll go a little quicker this second time drawing these triangles. So this time I have a side length of 6. 1, 2, 3, 4, 5, 6. My second triangle is, or my second side is 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then if I use my second graph paper here, again on my diagonal, right, I'm going from here to up here. And if I count that, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that one ended up being 10. All right, so if I look at my squares, if I draw my squares again, I can go 8, 1, 2, 3, 4, 5, 6, 7, 8. So again, an 8 by 8 square would be 64. I can go 6, 1, 2, 3, 4, 5, 6. A 6 by 6 square is 36. I'll use my second graph paper here to draw this square. Oops, not a very good square. And a 10 by 10 square is 100. All right, so that's my second picture. Okay, and then my final picture, I'm gonna go ahead and flip that over. I'll try it over here, was a 5 by 12. So if I draw 5 by 12, 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, I'm going to use my second piece of graph paper to find the diagonal. I'll line up those grid marks so I can see my diagonal goes from here to here, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to go ahead and draw those squares. Should have given myself a little more room. I'll eyeball that to up here. Oops, that wasn't a very straight line. There we go. 13 by 13 is 169. 12 by 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. By 12 would be 144. And then 5 by 5 is 25. All right, so those are my 3 drawings for those images on the front. All right, I'm going to switch back over to the notes. Oops. All right, so we just drew those first images. Again, if I do my sketches, you guys saw those before, but right, that was a 9 by 16, and then that box was 25. Okay, you can draw those similar pictures for the other ones, right? So 36, that was 64 and 100. And then the last one was 25, 144, and 169. All right, so then it says, what patterns do you notice? So if you were looking at those sketches we just did, what do you notice? So what I see is adding the two smaller squares totals the area of the larger square. So without having to use those drawings, what that would look like, right, if I had a side length of 7 and a side length of 9, that would be 49 and 63. So if not 63, 49 and 81, I multiplied those two numbers together. And if I added 49 and 81 together, that would give me 130. So my hypotenuse is going to be the square root of 130. Okay, because the area of that was 130, and the sides are the square of that piece. All right, so let's try another one. This one, they gave us the hypotenuse. So in my triangle, right, I know it's always going to look like a right triangle. The hypotenuse was 17, and one of the legs was 15, and I don't know the other one. So if I look, 17 squared is going to be 289. 15 squared is 225. So to find this one, right, I need to know, well, 225 plus what equals 289. So if I subtract, I end up getting 64 for the square. So if the square was 64, then I know the length would be 8, right? Because 8 times 8 would be 64. Or the square root of 64 would equal 8. So the side length would be 8. All right, one more like that. If the area of the square of one leg is 100, and the hypotenuse is 676, right? Then what is that other piece? Okay, well, if we do 676 minus 100, that's going to give us 576. And if I take the square root of 576, I'm going to use my calculator here because I do not know that. The square root of 576 would give me a length of 24. Square root of 100 is 10. And the square root of 676 is 26. So those are the measurements of the legs of my triangle. So we state the Pythagorean theorem. Again, given a right triangle with legs A and B and the hypotenuse is C, A squared plus B squared equals C squared. So using that formula, we can solve these other examples. So again, it doesn't matter which one you make A and B. So here I would do 5 squared plus 12 squared equals C squared. We actually already did this problem before. 25 plus 144 equals C squared. So 169 equals C squared. So to solve for this, we would take the square root, and we would say C is 13. I do not need the negative square root because we're talking about a triangle, and the length of a triangle will always be positive. All right, same thing in this example. So I'll say A is 3/10 squared, B is 2/5 squared, and then I don't know C. So that would give me 9 over 100 plus 4 over 25 equals C squared. I'll get a common denominator here. So 16 over 100. So then that would be 25 over 100 equals C squared, which would be 1/4. And if I take the square root of that, square root of 1 is 1, square root of 4 is 2. So I end up with 1/2 an inch. Again, I only need the positive answer for that problem. All right, last two examples. Here they gave me the hypotenuse, right? The hypotenuse is always across from the right angle. So this is my C value. So if I plug that in, A squared plus B squared equals C squared. 2.1 squared is 4.41. 2.9 squared is 8.41. I'm going to subtract. And I get A squared equals 4. So A would be 2. Right? Because I'm going to take the square root of that to get A by itself. All right, and then last one. Again, this one, they gave me the hypotenuse, right? That's my C value. So if I plug that in, A squared plus B squared equals C squared. That would be 256 plus B squared equals 1,156. We subtract. We get B squared equals 900. So we take the square root to get B by itself. And I only want the positive square root, so my answer would be 30. All right, guys, that is it for the notes. So you can make sure your packet is filled out and then return to the agenda to see what is next.